Today, I want to talk about the computing infrastructure of the 2030s, focusing on the collaboration between IOWN Global Forum and LF Edge on photonics disaggregated computers. Let me just start by my introduction myself. My name is Haruhisa Fukano from Fujitsu. I am working on the business and architecture planning about computing and network infrastructure for the 6G era. I have more than 10 years of experience in research and developing about heterogeneous computing and FPGA design for network equipment. About activity in communities, I joined LF Edge from the 2020 and became the Technical Advisory Council members from this year. And I'm also LF Edge IOWN Project Technical Steering Committee co-chair from 2023. In IOWN, we contributed OSS stack for building sensor network for robotics. Let me explain the outline of today's presentations. Firstly, I would like to introduce LF Edge and IOWN project as LF Edge member. Next, I will talk about computing challenges, including the edge computing towards the 2030s. And idea and activity to solve the challenges I will explain. And I will explain the photonics disaggregated computers proposed by the IOWN Global Forum, which is the key to solving the challenge. And also, LF Edge and IOWN Global Forum started proof of concept about photonics disaggregated computers. Finally, I'd like to introduce our upcoming schedule. So let me start about introduction to the LF Edge. In this slide, I want to talk about LF Edge community that I'm working in. LF Edge is an umbrella organization for edge computing under Linux Foundation. The goal of LF Edge is to create an open source framework for the edge computing. As an umbrella organization, we have several projects under LF Edge. As you can see, this figure, the project is divided into the 3 stages. From the at-large stage, which is startup phases, to the impact stage. Impact stage is market release phases. Each project has its own technical steering committees, which decides its management policy and operates independently. There are more than 30 sponsors in total. Fujitsu is one of the premier members since 2019. Next, I'd like to briefly describe each LF Edge project. There are a wide range of edge, including area code and edge, such as end-user terminals and on-premise, and also access and regional, and area code service provider edge that connected to the central data centers. And also each area are also layered from the infrastructure layer to the application layers. This diagram shows where each LF Edge project is located. In the user edge area, Infrastructure-related projects include IOWN. This is a lightweight OS for the Edge node, and also Open Horizon, which provide management container and also AI data management. And also Fletch. Fletch is a framework for the industrial IoT. And Edge Expander is a platform for the IoT edge devices. In particular, Acreno aimed to develop and publish edge use cases and OSS stack. So Acreno is a wide range project from user edge to the service provider edge, and also infrastructure layer to the application layer. For this reason, we, Fujitsu, has been working in the Acreno for ecosystem in the edge computing. This slide explains LF Edge Acreno. LF Edge Acreno is developing and publishing edge computing use cases and OSS stack for the edge use cases as blueprint to implement edge computing more easily. As shown in this picture, Acreno blueprint is OSS stack, use case based, integrated as end-to-end solutions, and also community proven and tested, and also community life cycle support, production quality. So using Acreno blueprint bring users, reduce the cost of implementing edge computing, and also reduce provisioning effort, and also can be deployed on the open hardware. As you can see this figure, Acreno published over 30 blueprints across a wide range of area, from the user edge to the service provider edge, and also from the infrastructure layer to the application layers. So this slide shows you activity of Acreno in 2024. As you know, AI is being used in variety of domains, and some use cases require low latency inference. So we decided to focus on the AI at the edge at the Acreno, such as low latency inference at the edge. As the AI-related blueprint, we will publish OCP-SC LF Edge Hackathon winning team idea as a blueprint. Please let me know if you want to implement edge use cases or publish OSS stack. We will help about this as a community. And also in this One Summit, LF Edge has a booth, so we are looking forward to your coming. So enough with the preamble. Let's get down to the main topics. I'd like to talk about challenges in computing for the 2030s. This is the start point. This figure shows you about the evolution of the AI model. The vertical line is the amount of the computation flops required to train each AI model. And the horizontal line is the year of the publication for each AI model. As you can see, the flops of AI model is growing at a rapid rate, about 23 times per year due to the generative AI evolutions. This is much faster than the speed of semiconductor evolution, which we call the Moore's law. So we are holding on this speed by increasing the number of parallel GPUs and making the system larger and larger. I think this will eventually bring us to a power consumption collapse. So another idea is that the system should be tuned to each AI model. But however, as the diagram on the right shows, the resource requirement for each AI model and also phases of learning, for example, learning and inference, are different from each. So I think coexistence of reducing power consumption and flexibility is challenging in the computing for the 2030s. To solve this challenge, the Linux Foundation and IOWN Global Forum has signed a MOU to collaborate. The IOWN Global Forum stands for the Innovative Optical and Wireless Network. They are working for innovation and implementation of new network and computing infrastructure for the 2030s. LF Edge, LF and IOWN Global Forum will integrate Linux Foundation software with IOWN Global Forum, a network and computing platform infrastructure to enable higher performance, low latency, and energy efficiency to meet growing data delivery demands. So in this slide, I will introduce IOWN Global Forum and also LF Edge Joint POC, which Fujitsu proposed as a specific initiative for IOWN Global Forum and LF Edge collaborations. As shown in this figure, the IOWN Global Forum has two working groups. Use case working group, which define the future use cases, and also technical working group, which define the reference implementation model and also new future technologies. And LF Edge has edge computing use cases, which defined by Acreno project, and also OSS stack by the Acreno, and also OSS for implementing each edge use cases. So, and also there are many common use cases between IOWN Global Forum and also Acreno. So based on the common use cases, we started to integrate LF Edge OSS stack on IOWN Global Forum infrastructure to prove affinity between each technology and also power, efficiency, and flexibility. In this slide, I will introduce the IOWN Global Forum infrastructure technology, which is the photonics disaggregated computer, which is the key technology for coexistence of reducing power consumption and flexibility. This photonic disaggregated computer has two features that are very different from existing computing architectures. The first is the disaggregation, allow for the flexible device allocations and reallocations. The second is to communicate data directly between accelerated device via photonics connections. As shown in this figure, the user request resources depends on their application. Then, photonics disaggregated computer controller instruct to the CDI management software, which CDI stands for the composable disaggregated infrastructure. Then CDI management software allocate resource from the resource pool, which connected to the PCI fabric switch, and also configure the PCI fabric switch and also optical switches, and allocate these resources as a service to the users. The next page will explain how these characteristics of photonic disaggregated computer coexist by reducing power consumption and flexibility. First, disaggregation. This allows for flexible device reallocations. For example, if each application requires different resources, as shown in this figure, the current computing architecture, which called server-oriented, allocated resource to each application on the per server basis. So this may leave some devices unused, like this. On the other hand, this aggregation can efficiently meet the requirements of various applications by selecting the required resource from the resource pools. Depends on the applications. And configure logical nodes through these PCI switches. As a result, disaggregation can flexibility response to the resource demands of various applications while optimizing resource utilizations and reducing power consumptions, because there are no unused resources remained. The second is to device communication via the photonic connections. As this figure shows, in the current computing architecture is CPU-centric. Data is transferred between accelerator devices via the CPU and also using the CPU memories. This causes that the CPU tends to be a performance bottleneck. On the other hand, in case of the device-to-device communication, data is directly transferred between the accelerators using the optical switches or shared memories. This reduces the utilization of the CPU core used for the data transfer, thereby reducing cost and power consumption. And also the processing delay can be reduced. Yeah. In this slide, I will explain about the detail of the joint POC, IOWN Global Forum LF Edge joint POC. We have implemented video inference and distribution as edge use cases using photonic disaggregated computers, and also LF Edge IOWN blueprint. As shown in this figure, we created the environment that simulate end-to-end services from the access area, edge cloud area, and also cloud area. The system received the video from the access area and pass it to the edge cloud area. Through the 5G RAN and also 5G core network, we used IOWN ICN blueprint for the RAN and core network for 5G. And also, edge cloud makes inference from the video. Here, we use the CDI product, composable disaggregated infrastructure product, and 100 gig switch to simulate photonic disaggregated computers. And also, we spread the video inference functionality and implemented it on the FPGA and also GPU as a decode, filter resize, and also inference functionalities. And we let the FPGAs and GPUs transfer data directly between the devices by the 100 key switch and also PCI switches. We use the Kubernetes to manage the infrastructure, and we use the IOWN IEC blueprint to summarize the related software stack. Finally, the processed video image is transferred to the cloud. This is our joint POC environment. So finally, I would like to explain our upcoming schedule. Currently, we consider joint POC in 2 steps. First, we have already done in the 2023. We confirmed integration of IOWN Global Forum infrastructure and LF Edge software stack. These results are also published as white papers from the LF Edge Acreno. Next is 2024, this year as a step 2. We are considering implementing other use cases and demonstrate performance improvement, such as flexibility, power consumption improvement. So we will explore new use cases and also implement new use cases and offload to the accelerators. To accelerate these community activities and solve computing challenges, we are looking for collaborators and also new use cases and technologies. If you are interested in, please join our community to accelerate solve these challenges. So let me wrap up my presentations. I said about coexistence of reducing power consumption and flexibility is challenging for computing towards the 2030s. We think photonic disaggregated computer is a key technology to solve these challenges. So IOWN Global Forum and LF Edge started collaboration and joint POC based on the photonics disaggregated computer and also LF Edge OSS stack. Yeah, let me introduce something about the Fujitsu booth and also Acreno activities and others. So Fujitsu has a booth at this One Summit. We are exhibiting photonic disaggregated computer, which I explained in this presentation, and also Edge Service Platform, which Peter Scorin, my colleagues, will explain in the next presentation. If you are interested in these topics and also to discuss, please visit our booth. We are looking forward to your coming. Yeah, and also here is the related information about the Fujitsu 6C era visions and also photonic disaggregated computers details, and also LF Edge Acreno white paper we have already published. I have already uploaded my presentation to the One Summit site, so please download from the link. Okay, thank you for your time today. Are there any questions or comment? Yeah.
Do you have any estimates on the efficiency for using photonic switching in the server?
Photonic switching? Yeah. Now, about photonic switching, we are just considering about what is suitable for us. So now, we are simulated by the 100 gig electronical switches. So I think the optical path switch, such as a mirror, is one of the candidates.
No, the question is, what's your hypothetical efficiency gain you expect with switching from a regular server PCI bus to optical?
You mean about the efficiency by changing the PCIe switch from the electrical to the optical?
Yes.
About that information, so far I have not. So for the next step about so I think in my understanding, the optical PCIe now defining the standardizations, and also the product will come. So after product appears, so we will try about this. I think. As any? Okay. Okay. Thank you for your time today. Please visit our booth.